Hello again, and welcome to video 2 in our spatial statistics example. This screen shows right where we left off. We did the scatter plot matrix and we ran the exploratory regression. I wanted to add this, that if you ever lose this button down, or if you ever lose this view details down here, like I just did right now, you can always go to Analysis, History. That's going to open yet another tab. But then if I right click on exploratory regression, I can go to view details. And then the only thing I have to do to finish is go to messages. You're going to have to be referring to details a lot during this video. So I wanted to put that out there in case you ever lose your details option at the bottom of geoprocessing. All right. So to start with, I'm actually going to turn off some variables that failed my test since there are so many. So this is not my layer. This is my layer. Right there. Stats variable 20. I don't know why that one's expanded. Meant to do that one. So I am just going to go to the attribute table. I'm going to open up fields. And I'm going to turn off primary care, mental health, limited access to healthy food, frequent mental distress, drug overdose, disconnected youth, segregation, homicide, suicide, firearm, juvenile, and that's it. And then again, I'm going to save. And what that'll do is those fields won't show up in any of the geoprocesses from here on out. And since they all failed, I'm never going to use them. So just a quick step to make things a little bit easier in the future. All right, so we are ready to run our first linear regression. So we're going to go to geoprocessing. Reminder, if you ever lose geoprocessing, analysis tools will open that window for you. And we are going to type in generalized linear regression. Notice how there are two of them. There's the geoanalytics desktop tools and the spatial statistics tools. Anything with this little diamond indicates that we don't have access to it. Also, we don't have access to geoanalytics in general, so make sure you're using the spatial statistics tools, generalized linear regression. For input features, going to use that stats variable 20 again. This is very similar to exploratory regression. My dependent variable is still poor mental health days, and now that I got rid of all the ones that failed, I can click select all. And then just make sure to uncheck poor mental health since that is my dependent variable. I don't need to fill in the distance features. I do need to give it a title. So the first time I ran it, I called it stats variable 20 GLR. You don't need to do the training model file or anything in prediction option. Just go ahead and run it. And when you do, this is what you end up with. So you'll notice there are a couple of pink counties poking through. Those are counties that had a null value for one of the variables, and so they are no longer part of the calculation. So I just went ahead and turned off that underlying layer. So this is the first thing you get this map. Even if I turn the states off, it's pretty easy to see South Dakota and a couple of the other states just kind of sticking out. But definitely turning on the states makes it a lot easier to see some of that regionality. So what you get is called standardized residuals. And basically what it means is an overestimation or an underestimation. A purple is an underestimation, green is an overestimation. The ones that are white are actually close. You're also going to get a series of 3 charts. Let me go ahead and pull up the view details on this one. Since I didn't actually run it, I'm going to have to go find it in my list. That is one problem with making the video after. Now, I can actually look at the output features. Oops. And under output features, I see the title I gave it, which is stats variable GLR. So I know this is the correct one. Now I can right click and go to view details. And within the messages, I'm going to see some information. So you can ignore this top column. Here are top row. Here are all of my variables and the data that it produces. So the first thing you want to look at is this probability column. An asterisk means that it passes probability. Not having an asterisk, like those three columns and that one right there and that one right there, actually show you that it failed probability. So we cannot be confident having those particular variables in the model that it's going to predict correctly. Same thing with robust probability. You'll see they fail in the same column, just with a different number. The other thing you want to look for is this variable inflation factor, or VIF. If this is over 7, that variable fails as well. So in this case, I do have a couple variables that are going to fail probability. Let me pull up my list. I'm going to move that off screen just so I can read it. The first one that failed is 004, which is primary care physicians. Oh, I must have left that one in by accident. The next one that failed is 23, which is unemployment. And then data 1 and data 3, this is percentage of households with high housing costs, and percentage of households that lack kitchen or plumbing facilities. Now, probably what happened here is that because this one passed, the other two failed. So this one passed right here, which is overcrowding. These were probably similar and failed due to multicollinearity. Then finally, this last one, number 58, is rural population. So in this example, that one failed as well. The next thing you want to look at is this R squared value. So the adjusted R squared is 0.89. So it's saying this data fits about 90% accuracy, which is pretty good. When we take some of those variables out, we'll make that better. So that's the first thing you want to do, is you want to read that report. Then you want to start looking at these charts. So double click on the chart to open it. Relationship between variables. What we're looking for here is any data that is really skewed. So this right here, which is percentage of households with high costs and overcrowding. Yep, it makes sense that that one didn't work. And then this one, overcrowding and public and kitchen facilities. Notice how skewed those two data sets are. So those have got to go. And they also failed probability. So it makes sense. For this next one, distribution of standard residuals, what you're looking for here is a mean of 0 and a pretty even bell curve. Not too bad. We're skewing a little high on the right, so we can make some adjustments there. Finally, the standardized residual versus predicted plot. What we're looking for there is a nice flat line at 0 and even distribution of green and purple. We're getting there. There's definitely some outliers on both ends, but again, once we take care of those variables, this should all improve. For your first GLR, you are going to need all of the above. Oh, not that one. You're going to need this map so you can export this layer, and you are going to need these 3 charts. So format this the way you want it. Take a picture, take a picture, take a picture. They might come over when you export this layer. I've had mixed success with it, so you might have a chart Otherwise, as long as your screenshot is clear, you're good to go there. Going back to this chart, you now start to see where this is filling in. So there's percent unemployment failed probability, high housing cost failed probability, percentage of households, kitchen, and plumbing facilities failed probability, everything else passed. So we're good there. It's good to keep this chart while you're doing the project. That way you don't have to remember and look for it later. All right. So now that we've run our GLR and we know which variables to remove, we're going to run it again. So I'm going to go ahead and close these three charts. Back to my map. I'm going to go back to geoprocessing. And since I just ran this tool, everything's still filled in. So all I have to do is remove the variables that failed, which was unemployment, high housing costs, plumbing facilities. And then I'm just going to change the name to GLR2. And I went ahead and ran that. So what you're going to see here is docking is sometimes challenging. GLR1, and then when I turn on GLR2, this is what it looks like with those changes. So you'll notice some changes here or there, but not a lot of overall changes because it was already fitting the model with about 90% validation. We'll see if we can get a little bit higher. So now let's find the messages for this GLR2. So I'm going to go back to my history. Hopefully it's this one. And it is. So I'm going to right click, view details, messages. And now all of my probabilities have passed. So, oh, nope. Still have 2 here. 3 here. Maybe I'm in the wrong section. Let me try this one. Yep, I just opened the wrong report. That's on me. So notice how all the probabilities passed, all the robust probabilities passed, and the variable inflation factors haven't changed. And then finally, if we look at our adjusted R-square, we've got a little bit higher. We're now up to 90 as opposed to 89. So not a huge change, but still a little bit of a change. It is an improvement. So what you would do in that case is if you get it in 2, you would go ahead and export the second layer, take pictures of the charts. That's what it says in the directions. If it takes you 3 or 4 tries, then just make sure you do the first and the last so you can see any differences between them. Last thing we're going to do in this video is we're going to run a tool called spatial autocorrelation. Spatial autocorrelation, Global Moran's 1. It's also in the Spatial Statistics toolbox. Go ahead and click that. You have to run the generalized linear regression to run the spatial autocorrelation. So again, like I said, these are called residuals. Purple means it's an underestimation, green means it's an overestimation. We need to find out if these are clustered, and it's really clear that they are. I mean, South Dakota is a prime example. It stands out even when the states aren't put in. So we kind of already know the answer to this, but it's always good to prove it. So input feature this time is not going to be the stats variable 20. It's actually going to be the second GLR. It's going to be this GLR2. And the input field is not the poor mental health days. It's actually at the bottom and it's called standardized residual. So you can choose that. Make sure you click this generate report button. Then spatial relationship, we're going to change it from inverse distance to k nearest neighbors. And for the first time, we're just going to run it with 8 rows. We're going to do the standard. We don't know how many neighbors it's going to take. So we're going to go ahead and run. And when I view details on this, it doesn't really give me a whole lot. If you know p-scores and v-scores, you might know what this means. P-value of 0 is great. Z-score of 50 is not. But it does have a little printout for you. So if you click that, and then you move it to the screen where you can actually see it, you can see that we are indeed clustered. Anything over 2.5, 50 being way over 2.5, is clustered. And again, so that what that means is there's less than a 1% chance that this pattern is random. And again, we kind of know that. We know that from just looking at the residuals. So generalized linear regression does not take into account space. It's just a mathematical calculation. We're now going to run a tool called geographically weighted regression in the next video, and I'll see you there.